we'll be using the results of example 11, which says that the velocity for the pendulum will be small m plus big M over small m times 2 times g times height. And so height is what we're interested in here. We have all the other quantities. So h is just rearranging this equation and taking the square of both sides. H is just mv over m plus big M squared times 1 over 2g. And so let's plug in those values here. 28 grams, which is m, is 0.028 kilograms. V is 210 meters per second over 0.028 plus 3.6 kilograms. Quantity squared times 1 over 2 times 9.8 meters per second squared. All right. So the height comes out to be 0.13 meters. That's the height to which the pendulum swings from its initial position. So let me draw out the scenario for what we have so far right now. Okay, so we here's where the pendulum swings from, and so this is the entire length of the pendulum L. It swings up to here. So this is also L. Let me just erase this part to make it look more even. So that's also L, and so it swings up to there, and so this is obviously not to scale, but the idea is that this whole thing is L, and this part here, going over there, is L minus H. And so this little bit here from the point, the highest point to which the pendulum swings to the original length of the pendulum, this is H. Okay, so that is L minus H. So this is L minus H. This is what we want, denoting that by green. So this is L minus H. This is L, and this right here is X. So that's the horizontal position we want. Okay, so X, therefore, or rather, let's just solve Pythagoras, the Pythagoras theorem here. Use the Pythagoras theorem here. L squared, the hypotenuse squared, is horizontal squared, x squared, plus vertical squared. Vertical is L minus H squared. Therefore, x squared is just L squared minus L minus H squared. And so, or rather, the square root won't come out here, but x is just the square. It's just the square root of that, right? So x is square root of minus L minus H quantity squared. And L, as we know, is 2.8 meters squared. That is squared minus 2.8 minus 0.13 meters, as we just found, quantity squared. And that was the whole point of finding H here, is so that we could put that in there. And so the answer comes out to be 0.86 meters or 86 centimeters for horizontal displacement.